So, to continue with our units, the title of our next lesson then, after we've done our review of factors, multiples, squares, and cubes, is factors of a polynomial. What is a polynomial? Polynomial is an expression that can have any number of terms. So some examples of polynomials would be 4m plus 12. That has two terms. Or 3m could be a polynomial all by itself. Or you could have a polynomial with three terms, x squared plus 4m plus 12. All examples of polynomials where you're dealing with a combination of numbers and variables, and also where we have a variable attached to a number, right? That is, name escapes me right at the moment. Without a variable, they're a constant. And then we can have a single variable like x squared, that's a variable, and 4m, a coefficient, a number attached with a variable, a coefficient. Okay, so those terms aren't a significant thing right now. They're just brief review for you of previous concepts. They don't really play into today's lesson, so we won't write them down. I'm going to flip over to page 152. And I will draw examples from there. So the first thing I'll do is write down several different examples that I'm simply drawing from page 152 in your text. 6n plus 9, 6c plus 4c squared, 3g plus 6, and 8d plus 12d squared. Now, let's start with 6n plus 9. How do we factor 6n plus 9? Well, what are the common factors of 9 and 6? Right? 6 has 1, 2, 3, and itself. Right? 2 times 3 and 1 times 6. 9, you have 1 times 9 and 3 times 3. Right? So they only have one common factor, and that's 3. So we don't even have to worry about what the greatest common factor is, because the only one they have is 3. So we factor out a 3, and we set up a bracket. Now, 3 times what equals 6? 3 times 2. The n did not have any common factors, so it's going to remain. 3 times what is 9? 3 times 3. So the way you factor 6n plus 9, you factor out a 3, and then in your brackets you have 2n plus 3. And of course you can multiply this and get 6n plus 9 again. 3 times 2 is 6, that's 6n, and 3 times 3 is 9, that's 9. That's the idea. So factoring. And then if you factored correctly, you should be able to multiply the factored expression and get the same answer again. So here we have 6 and 4. Now, what is the greatest common factor of 6 and 4? Again, 1 times 6 and 2 times 3 for the 6, because it's repeating itself. 4, 1 times 4 and 2 times 2. These are small numbers, so it's very easy to find. Obviously, it's 2 is the common factor. But we have something different here. Both numbers have a variable. 6 has a c and 4 has a c squared. If they both had a c squared, then we could factor out a c squared. But 6 has a c and 4 has a c squared. Therefore, we can factor out a c. We can factor out 2c. So here we say we factored out the c, 2c. 2 times what is 6? It's 3. And this time we don't need to attach the c because we factored it out. 2 times what is 4? It's 2. 2 times 2 is 4. And this time we put a c beside the 2 because the 2 has a c squared. In other words, a c squared, the 4. In other words, it has 2 c's. This one has only 1 c, this one has 2. This is c times c. This is just c times 1. So this has 1, this has 2. So if we're only able to factor out 1 because the 6 only had 1, then we have to put 1 inside the brackets so that this is still a c squared. So 2c times 3 is 6c. 2c times 2c is 4c squared. Get the same answer again. Hope it's clear so far, but there are a couple more examples here to help. A 3g and a 6. Again, one number does not have a variable, so we don't factor out a variable. That's the same as the first example. So 3 and 6 common factors. We've already factored the 6 before. We know it's 1, 6, 2, and 3. What are the factors of 3? It's a prime number, so there's just 1 in itself. So 1 and 3, obviously the greatest common factor here is 3. Factor out the 3, set up your bracket. So we pull out the 3, we're left with only the g, because this is the same as 3 times 1, which will still give us 3 times g is 3g. 3 times what equals 6? 2. So 3 times g is 3g, 3 times 2 is 6. 8 and 12 over here. What is a common factor of 8 and 12? Well, for the 8, you have 1 and 8 and 2 and 4. I think that's all of them. For the 12, 1 and 12, 3 and 4, 6 and 2. So they have common factors of 2 and 4. So we use the 4 because it's the biggest one. If there's 2 factors, which is the first one we've encountered so far that has 2, we use the 4. It's the bigger one of the 2. They both have a variable. We can factor out a d here, 1d, and set up our bracket. 4 times what equals 8? 4 times 2. And the d is factored out, so we don't have to add it. 4 times what equals 12? 3. 4 times 3. And we put a d in because we factored 1 out, and there's 2 d's up here. So we need 1 here and 1 here to make this work. 4d times 2 is 8d. 4d times 3d is 12d squared. All right. Shall we continue on with some more of this concept? Yes? All right. So I'm going to pull a couple of examples from page 153. This time they're getting a little longer. 5 minus 10z minus 5z squared. Well, do copy one at a time this time. So 5, 10, and 5. What is the common factor of all of these? I think it's pretty obvious. 5 is a prime number, so it's only going to have 1 and 5. So, and 5 is also a factor of 10 because 5 times 2 is 10. The common factor we're looking for here is 5. One of the numbers doesn't have a variable, so we're not factoring out a variable. Set up our bracket. 5 times what equals 5? 1. 5 times what equals 2? Or 5 times what equals 10? 2. And that's a negative, so we leave it as a negative. 2z. 5 times what equals 5? That's again times 1, but we don't have to put a 1 in here. We can just put in the z squared, which is the same. If there's a variable, then the variable can stand for the 1. Remember how that goes? 5 times 1 is 5. 5 times negative 2z is negative 10z. 5 times negative z squared make a crisper z. Negative z squared is negative 5z squared. Let's do another one here. 6 minus 12z plus 18z squared. Looking again for the greatest common factor. 6, 12, and 18. Well, we already know what 6 has. It has 1 and 6, 2 and 3. Is 6 a factor of 12? Yes, it is. 6 times 2 is 12. Is 6 a factor of 18? Yes, it is. 6 times 3 is 18. So we can use 6 here. 6. What do we put in the bracket first? 1. 12z. There wasn't a variable to factor out because the 6 doesn't have one. 12z. 6 times what is 12? 2. Minus 2z plus, let's have a plus here. 6 times what is 18? 3. Z squared. Now we can check. 6 times 1 is 6. 6 times negative 2z is negative 12z. 6 times 3z squared is 18z squared. So if you know your factors and your multiples from the previous lesson, this stuff doesn't have to trick you out at all. It's easy to do if you know your factors and your multiples. And with that in mind, let's try factoring a couple of longer ones. On page 154, there's a couple of examples there. I probably won't give you, there's like in your homework, there won't be anything quite, well, yeah, probably not quite as difficult as this, but yeah, maybe. So, let's have a look at this one then. Negative, again, this is from 154, negative 12 x cubed y minus 20 x y squared minus 16 x squared y squared. So we're dealing with, they've all got variables, so we can already see we're going to be factoring out some variables too. But first, we want the greatest common factor of 12, 20, and 16. 12 has 1 and 12, 2 and 6, 3 and 4. 20 has 1 and 20, 4 and 5, 10 and 2. So far I'm seeing 4 as the greatest common factor between these two. 16 has 1 and 16, 4 times 4, and 8 times 2. 8 didn't show up for either of these. The 2, they all have the 2 in common, but the 2 is smaller. So we're looking at factoring out a 4. Now, which variables can we factor out? This has an x cubed, this has an x by itself, this has an x squared. So you factor out the smallest x, which is a single x by itself. Can we factor out a y? Single y squared, yes. This has a single y that can be factored out. So 4xy, set up your bracket. 4 times what is 12? 3. We factored out an x, so we can, and there's 3 x's here, so we only need to put 2 because there's one factored out. And the y is factored out, a single y, that can stay. Minus 4 times what is 20? 5. The x, the single x is factored out, we can leave that. There's a y squared, a single y is factored out, so we need just one y. Another minus here. 4 times what is 16? That's 4 times 4. X is factored out, we have an x squared, so that's a single x. And we have 2 y's, one is factored out, so just a single y. And if we multiply through to check, we will find 4 times 3, 4 times 5, 4 times 4, and it all checks out like that. Let's do one more example here. Negative 20 C4D minus 30, C to the 3, 2Ds, minus 25, C, D. Again, they've all got variables, so we can see that we'll be factoring out a variable, but let's find the greatest common factor of all these numbers first. Focus on the 25 here. 25 only has two sets of factors, 1 times 25 and 5 times 5. So it's got 1, 25, and 5. The 1 isn't really relevant, that won't change anything. Do 20 and 30 have 25 for a factor? No, they don't. You're not going to multiply 25 to make either of these two numbers. We're clearly dealing with the 5. So we're going to factor out a 5. Oh, I forgot about the variables. Let's just scribble that out. 5. Look at the C. A 4, a 3, and a single C. So we can factor out a C. The D, a single D, 2 Ds, and a single. So we can factor out a single D. Now, 5 times what equals 24. And this is a minus. So minus 4. C to the 4. We factored out a single C, so it becomes C3. We factored out the single D, so we don't need to put it in. Minus 5 times what is 30? That's 5 times 6. We've got a C and a D factored out. This is 3 C's, so we need to put 2 inside the brackets. 2 D's, and there's 1 factored out, so just 1. Minus 5 times what is 25? 5 times 5. A single C and a single D that are already factored out. We're done. Your homework, some of which will count as marks. So pay attention to what I lay out here. Page 155, number 7 and 8. Then, number 9 on the same page, number 9 for 10 marks. So you've got 2 assignments for marks. The check your understanding of factors, multiples, cubes, and roots that I assigned earlier. And then this one as well, page 155, number 9 for 10 marks. All right, let's just have a look at those particular questions. Done a bunch of examples that are just like them, so you should be okay. Here you can see number 7. You would, for the first one here, you would factor out a 5, and you would have y plus 2 in your brackets, right? And you have this one here, 9 and 12. And you could factor out a 3. You could also factor out a b squared, because there's 2 b's here and 3 here, so you could factor out 2 b's. So you would approach this one. And we're not using algebra tiles at all. Do all this on paper like I showed you. Don't worry about algebra tiles. We're not really using them at all. Don't need to. Use them before. So here, this is the one that counts for marks. 9, number 9, A. Number 9, A to F. So the first one here, you would factor out a 3, right? Because there's 3, 12, and 6. The greatest common factor would be a 3, because 3 is a prime number. So that's all you're going to get for factors. And 3 is a factor of 12 and of 6. So you factor out a 3, then you set up your bracket. And there's that one. And this, factoring these 6, what are called trinomials. Remember, polynomials can have a single term, which is a monomial. It can have 2 terms, which is a binomial, bi for 2. And then trinomial, 3. It can also have 4 terms. We're not factoring any with 4 terms, although we could, but we're not. So, alrighty, leave you with that again. And that question number 9, worth 10 marks. You should have written that down already. So we will close this recording. That's it for math for the week of December 7 to 11.